Hello, this is part two. This is part two of implicit differentiation. So this is the second part. We're going to do example 3 and example 4. So on example 3, it says find dy dx. So we're going to do implicit differentiation. So let's start. So you're going to take the derivative of each term. There's exactly 1, 2, 3, exactly 4 terms. So we're going to take the derivative of each term in respect to x. So starting with x cubed, the derivative of x cubed in respect to x is 3x squared. And then you have the option of putting dx over dx. But you know that it just becomes 1, so you don't have to put that if you don't want to. Now, this one, the derivative of negative 3x squared y, how do you take the derivative of this? You have to apply product rule. So this is the tricky part. So let's apply the product rule. So if you recall, that product rule is f prime of g plus g prime of f. So first figure out your f and figure out your g. So your f is, I'll call it my f as negative 3x squared. F prime is, so we're taking the derivative of this in respect to x. So the derivative of negative 3x squared is negative 6x1. And then in respect to x, you do have the option putting dx over dx, but we all know that that just becomes 1. And then g is y. And then g prime is 1. In respect to x, you do have to, since we got to take the derivative of this, so the derivative of y is 1, but in respect to x, you have to add that dy dx. Okay. And then just apply product rule. So it says f prime of g plus g prime of f. So f prime is negative 6x, and then you don't have to put the dx because that just becomes 1. And then times it by regular g, which is y, plus g prime is 1 dy dx, times it by regular f, which is negative 3x squared. Okay, yes, I will clean that up. So also, I'll clean that up later on. So now we also don't forget about this 3x, so bring this down. 3x squared dx over dx, you don't really have to put that because that just becomes 1. Now let's take the derivative of 2xy squared. So how do you take the derivative of that thing? You have to apply product rule again. So let's first figure out our f and our g. So my f is 2x. F prime is 2. G is y squared. G prime is 2y. So product rule is, whoops, what am I missing? For the g prime, it's 2y, and then you were taking it in respect to x, it's dy dx. So product rule is f prime of g plus g prime of f. So f prime is, so it's plus, and then f prime is 2. Regular g is y squared. Oh, also, by the way, f prime in respect to x, you do have the option of putting dx over dx, but that becomes 1. So that's, I just want to make sure that that's why I just put 2. And then plus g prime, which is 2y dy dx, times it by regular f, which is 2x. Okay, and then on the right side, the derivative of 12 or a constant is 0. So let's just kind of clean this up. So this is 3x squared. This is negative 6xy. This is going to be negative 3x squared dy dx plus 2y squared. And then 2y times 2, that's 4xy 4xy dy dx equals to 0. So remember when what we're gonna do is get anything with a dy dx on one side and anything that doesn't have a dy dx moved on the other side. So this one thing has a dy dx. This also has a dy dx, and you have this 3x squared, negative 6xy, 2y squared. They don't have a dy dx, and you cannot combine them, so just move it all on the other side. So let's move everything to anything that doesn't have dy dx, move it on the other side. So starting with this 2y squared, to move it on the other side, you have to subtract 2y squared. Same thing with this negative 6xy. To move it to the right, you have to add 6xy. And then this 3x squared, subtract 3x squared. So this cancels, and then I'm going to need more space. So I'm going to go ahead and pause. I'm going to erase this part right here because I'm running out of space. Okay, so now on the left side, you have negative 3x squared dy dx plus 4xy dy dx. And then on the right side of the equation, you have negative 2y squared plus 6xy minus 3x squared. Okay, and then on the left side, they both have a dy dx. That's good because now we can factor out that dy dx. So that's dy dx, and then this is going to be bracket negative 3x squared plus 4xy, and then on the right, it's negative 2y squared plus 6xy minus 3x squared. Okay, to solve for dy dx, you have to get rid of this whole thing. So to do so, you're going to divide both sides by negative 3x squared plus 4xy. So you get dy dx equals to negative 2y squared plus 6xy minus 2y squared. So on the numerator, you can rearrange it slightly different. It's still not going to be wrong. And then on the bottom, it's just going to be, so on the bottom, you have negative 3x squared plus 4xy. If you want, you can take out an x, right? So if you took out an x, it would be x parentheses negative 3x plus 4y. Okay, that's pretty much it for this is your final answer. Okay, go ahead and pause whatever you have to do to write down the work and the answer. I will move on to the next example. Okay, let's move on. So this is the next is the last example, and then we have a quiz. So example 4 says find the equation of the tangent line to the graph of the given point. So they actually want an equation. So there's actually two things we need to find. We got to find slope because they don't give us that. And then the equation. So when they say find the equation of the tangent line, that's a big clue that you would use point slope form. So point slope form, if you forget, this is what it is. It's a linear line. It's y minus y1 equals to m times x minus x1, right? So that is point slope form. So first, let's find slope because we need that to put it in this equation, right? So how do we find slope? And they also give us the point at 4, 0. So point slope form. So how do we find slope? So we're gonna just take the derivative, right? Implicit differentiation. So let's start with the left side. We have parentheses y minus 2 squared. How do we take the derivative of that in respect to x? You apply power rule and chain rule. So this would be 1. So 1 times 2 is 2. And then you have y minus 2. And then the new power will be 1. And then you apply the chain rule by taking the derivative of the inside. So what's the derivative of y minus 2? Well, the derivative of y is 1. The derivative of negative 2 is 0. So it's really 1. But since we're taking it in respect to x, you do have to add that dy dx. And then what about the right side? The derivative of this whole thing? How do we take this derivative? Do not apply product rule because 4 is a constant. So what you would do is just take the derivative of x minus 3 for right now. And then since 4 is a constant, take it out and then put it back, bring it back in when we're done. So let's take the derivative of x minus 3. You know what? If you want, you could just boil it out, right? So this is going to be 4x minus 12. And if you take the derivative of that, that is going to be the derivative of 4x is 4. In respect to x, it's dx over dx. You don't have to add this because this just becomes 1. And then the derivative of negative 12 is 0. Okay. So yeah, now you have 2 parentheses y minus 2 dy dx. This cancels. Let's try to get dy dx by itself. So what do I have to do? I could FOIL this 2y minus 2, right? Or I could just get rid of it by dividing both sides by 2 parentheses y minus 2. And then this cancels. So remember, slope, this is not our answer. Slope, what is slope? It has to be an actual number. So this is why they give us this 0.4, 0. That's 4. And then all you got to do is replace our y value. We do have a y value at 0. So it's 0 minus 2. And then 0 minus 2 is negative 2. So that's 4 over negative 4. And then that gives you negative 1. That's just our slope. That's not our actual answer. But I'm going to circle it because I'm going to put it back in. So now we're going to go back to point slope form because they want an equation. So it's going to be y minus y1. So y1 would be 0. My slope is negative 1. And then it's x minus x1, which is 4. So this is negative 1x plus 4. And then y minus 0 is 4, y. And that's your final answer. Your final answer is y equals negative 1x plus 4. Okay, so on this one, we had to find point slope. We had to find slope. We had to also use point slope form, and we had to do implicit differentiation. Okay, so that wraps it up for this section. Thank you. Bye.